Hey everyone, my name is Anson. We're back with a brand new video. In this video, I'm going to show you all how to set up a GraphQL server in NestJS. So this by no means is a beginner tutorial. There is already implication that you have worked with GraphQL. You have some experience with GraphQL. This tutorial is mainly for people who want to actually set up GraphQL with NestJS. They want to use GraphQL in their NestJS project. Okay, so obviously you need to, one, know how to use NestJS, and two, know at least some basics of GraphQL. Okay, so if you don't know GraphQL, though, I do encourage you to read up upon it, look up a tutorial explaining what GraphQL is, and then come back to this video. But I will do my best to kind of like hold all of your hands to just kind of like guide you through how to set everything up. So even if you don't know GraphQL, I'll still try to like baby you all through this whole process. Okay, in a way that doesn't make it seem, you know, too boring for those who already know GraphQL already. I'll try my best. But anyways, let's go ahead and get started. So I'm not really going to go in depth with what GraphQL is. I'll just mention that GraphQL itself is a very powerful query tool that you can use. Instead of using the traditional REST API, you can use GraphQL to query your data, which is basically the alternative to making a GET request to get data. And then you can use what's called a mutation to create data, update data, stuff like that. Okay? And one of the biggest problems that GraphQL solves is overfetching and underfetching, because there are times where you will interact with a REST API that gives you a bunch of unnecessary fields, a bunch of unnecessary data that is taking up bandwidth when it's being sent back to the client. And sometimes it's just unnecessary to have all that data because you're probably never going to use it. So with GraphQL, you can basically target specifically what fields that you want, okay, and you'll get exactly what you ask for. So if you don't ask for, certain fields that are part of that API call, then you won't get it. Okay, or in this case, the GraphQL query. It also prevents you from underfetching because you can literally just set up a query that gets you the bare minimum data that you need for your application. So that's one of the reasons why many people use GraphQL. It also solves the issue with relational data at the kind of like the client level. Whereas if you're using a database like SQL would solve the relational issue at the database level. So GraphQL does, in a way, allow your data to be relational, because it's kind of like combining a bunch of records all together into one single response that's being sent back to the client, and all of those data that is being resolved back to the client all has relation with each other. Okay, it's kind of like a graph where it all kind of connects to each other in some way. So hopefully that brief little explanation makes sense. Okay, let's go ahead and set up a project and then install some of our dependencies. So obviously first, make sure you have the Nest CLI installed. I'm assuming all of you that are watching already have experience with Nest, so I'm not going to go over that. It's going to go into my terminal, my Windows PowerShell, and I'm going to use the Nest CLI. So I'm going to type nest new, and I'm going to type GraphQL tutorial NestJS. This will generate a project for me. I'm going to use npm as my package manager. And while it is setting up the scaffold of our project, I will mention one thing. By default, many of you should know this by now. If not, I will explain again. NestJS does use Express underneath the hood, or it's built on top of Express. And it uses Express for many of its features. Okay, but if you want to use Fastify, which is an alternative web framework than Express, you actually can use Fastify. But if you do use Fastify, though, and if you want to follow along while also using Fastify, you have to install different dependencies. Okay, so right over here on the top, I'm going to be installing these 4 dependencies right over here: NestJS/GraphQL, NestJS Apollo, Apollo Server, and then GraphQL. If you're using Fastify and you're also wanting to use the Apollo server as well, then you'll reference this line right over here. All of these dependencies are the same except for this one right over here, as integrations/Fastify. Let me zoom out a little bit. Okay, but if you're using Fastify and you don't want to use Apollo, but you want to use a different driver. It's called Mercurius. You can just install these dependencies. I'm going to, like I said, I'm going to be using Express and Apollo, so I'm going to install these dependencies. But it shouldn't really make much of a difference in terms of writing the code. Okay, so I'm going to go ahead and copy this command right over here. I'm going to go back to my Windows PowerShell. I'm going to cd into that project that I just created. So GraphQL tutorial NestJS, and all of the code that I'm going to be writing in this video will be in a GitHub repository, and I'll leave a link in the description to that GitHub repository. So that way you all can use it as a reference. So I'm in my project folder right now. I'm going to go ahead and paste that npm command to install all of my dependencies. Okay, so once again, that's just these four. So let's just do that. Okay, cool. So it's done. Let's open up Visual Studio Code. Okay, awesome. Now what I'm going to just quickly do is I'm going to remove a couple files that we're not going to need at all. So I'm going to remove this spec file, the controller file, the default ones that have been generated. I'm going to remove the service file because we're not going to need this one. I'm going to go inside app.module.ts and remove these two imports, and then remove these two references because they no longer are relevant. And that's pretty much it. So let's go ahead and run our project just to make sure everything is good. So we'll type npm run start :dev to run the dev script. Cool. All right, so we have our GraphQL packages installed. Let me just verify that. Yes, I have Apollo server. I have all of our packages installed. Great, that's wonderful. So now what I need to do is I need to go into app.module.ts, the root module, and I'm going to go ahead and import GraphQL module from the NestJS/GraphQL package at NestJS /GraphQL. I'm going to go inside the imports array, and I'm going to go ahead and reference GraphQL module just like that and call the static for_root method. Okay. And this is what initializes the actual GraphQL module itself. We do want to pass in a couple of options. I will type annotate this for_root method call to Apollo config or Apollo driver config. Okay, this ensures that I don't provide properties that are for a different driver. In this case, we're using Apollo. So I'm just going to make sure. You don't have to do this part, but I think it's a good idea to do it anyways. So now what I'm going to do is I'm going to set the driver to Apollo driver, and this is going to be a class that actually is imported from at NestJS /Apollo. So since I already have that up top over here, I'll just add Apollo driver, just like that. Okay, cool. So we're done with this part. Now what we can do is let's look at our console. And you'll see our logs. We are going to get an error, and that's totally normal because we don't have any root query right now. We need to actually create a query. In order to do that, though, we first need to actually create a type, and then we need to create a resolver class, and inside the resolver class is where we will define our queries, which they're just really just functions. Now, one more thing that I did forget to mention is that in NestJS, there's two ways that you can actually use GraphQL. There's the code first approach, and then there is the schema first approach. There's pros and cons with both. It's really up to you. I'll show you an example that the documentation has with code first versus schema first. So if you look at this example with code first, where is it? Right here. Trying to find it. Right over here. Okay. So if you look at code first, you'll see that instead of using the traditional schema definition language, you're actually going to be using the language that you're using to write your application. In this case, it's TypeScript. So we're going to be using TypeScript classes to create our models or our GraphQL types. So you can see over here in this example, they have an author class, and they use decorators to annotate each field as a GraphQL field. Okay, and we'll go through all of this when we create our own type, so don't worry. This is what it looks like with a code first approach. And this is really good if you want to make sure you keep your whole code base consistent with, just TypeScript. You don't want any GraphQL language at all. So again, it's up to you on what you choose to do. If you want to do a schema first approach, you can use the GraphQL schema definition language to create your type. So this is what it would look like. Whichever one you choose, in the end, NestJS will take care of generating the appropriate definition. So if you're using schema first, it will generate appropriate interfaces for you so that you can use it to type annotate your stuff, your properties. If you're using code first, it will generate those classes into a GraphQL schema into one file, and I'll show you that later as well. Okay, so hopefully all that makes sense. But in this video, we will be using code first approach. Okay, so let's go ahead and go into our source folder. I'll create a new folder and I'll call this GraphQL. And I'll go ahead and create another folder inside GraphQL and I'll call this models. Now I'll create a file and I'm going to create a simple model. I'll call this user. Okay. And now what I'll do is I'll create a class. I'll call this class user. And in order to tell GraphQL that this is a type, we need to use this object type decorator. Okay, now we need to import that. So let's import that from @nestjs/GraphQL, just like that. This is a decorator. Okay. And then now we also need to define our field. So it's very similar to how you would define fields normally in a class. So I'm going to define an ID field, which will be a number. And then what I need to do to tell GraphQL that this is an actual field, because like I said, Nest is going to translate this class into an actual GraphQL schema in its own file. So we need to make sure we are using these decorators appropriately. So I'm going to use this field decorator, and we need to import that from the same package, NestJS/GraphQL. And then I'm going to invoke this function because the decorators are really just functions. Okay. Now, one thing that I will also do is create another field. So I'll use the field decorator, and I'll call this field username, and this will be of type string. And then I'll do another one, display name, and I'll call it string as well. Okay. Pretty straightforward. Okay, nothing too complicated. Now, one thing that I do want to mention is that when you're working with numeric values, you need to make sure you actually pass in this type function inside the field decorator. So it'll look something like this. Type, and then it'll return this int. We have to import this from NestJS GraphQL. So this will ensure that this ID is actually an int. You can actually do float as well. There's also another import called float. Okay, but you need to make sure you do this because if you don't, by default, it'll generate the schema and it'll recognize this ID as a float. In this case, our IDs typically are integers, not floats. So you want to make sure you take care of that. And you only really need to do this when you have the number type. You don't have to do this if it's a string or a boolean. So I don't have to do this for username or display name. Okay. I'll show you another example of how we can handle nullable values for our fields as well. So I'll leave username as a non-nullable field, but for display name, I want that to be nullable. So I'll add the question mark operator right in front of this property. So that will just tell TypeScript that this is nullable, but it won't tell GraphQL that it is. Tell GraphQL that it is nullable, you have to pass in this object and then set nullable to true. So when the actual schema gets generated from this TypeScript class, you'll see that the appropriate operators are applied, the appropriate symbols are applied to the fields. And you'll see that once we actually have the file generated. Right now, it won't be generated because we actually need to use this GraphQL model. In order to use it, we first need to create a resolver. Okay, so hopefully so far everything makes sense. We simply just created a class, we defined our fields, and we used the object type decorator to annotate our user class to say, hey, this is going to be, a GraphQL type, and then we used the field decorator to annotate our class fields, saying that this is going to be a field inside our GraphQL type. That's all it is. Okay, let's go ahead and close this out. And what we'll do is we'll create another folder inside GraphQL. I'll call this resolvers. I'll create a file and I'll call this user resolver.ts. Now, inside this user resolver file, we're actually going to create our user resolver class. Now, I know I didn't mention what a resolver is, and again, this is where you need to make sure you know your GraphQL terminology. But for those of you who are not too familiar with resolvers, basically a resolver is a way for you to actually interact with your data. The primary goal of the resolver is to actually populate your data with the correct fields, or populate your fields with the correct data. Sorry, I got it the other way around. Populate your fields with the correct data, and it'll go ahead and get that data from either the database or an external API or whatever data source it needs to get it from. Okay, that's what the resolver is responsible for. In NestJS, though, it is done a little bit differently because we do need to create the resolver class, and inside that class, we're going to actually define our queries using methods and the query decorator. So I'll show you how that works. So first, let's go ahead and create this user resolver class. Whoops. We're going to need to use the resolver decorator. And before I do anything else, let me import resolver, and that should come from the GraphQL package. My imports are messed up right now, but I need to restart my TypeScript server, but I'm not going to do that. It's okay. So what I'll do next is inside this user resolver class, what we want to simply do is just create a method that is going to be responsible for querying our data. So if I wanted to get the user itself, then what I would do first is I would create a method and I would call this getUser. You can call it whatever you want. I'm going to call it getUser. And this method can return whatever you want, but typically it should return the data corresponding to the resolver. In this case, it's going to be a user. Okay, so for now, I'll just I'll just return a fake user. So ID of 1, username, Anson. Display name is optional, but I will provide a display name. And we'll call it Anson the developer. We'll set that value to be Anson the developer. To tell GraphQL that this getUser method is a query, I need to use the query decorator. And this is not coming from NestJS common, but from GraphQL, the GraphQL package. Okay? NestJS GraphQL package. And what we're going to do is inside the decorator argument, we're going to pass in this optional function. And we're going to say returns. And we're going to specify what it returns. We actually have to do this, so that way GraphQL knows what it's supposed to return. All right, so now GraphQL will know that this query will return a user. Okay, so we'll leave it like this for now. Let's go ahead and take our user resolver. We need to go inside and register the user resolver inside the app.module.ts file. So if you've used NestJS before, which again you probably already did if you're watching this video, you'll know how to register providers. Okay, those are pretty much like services, repositories for your data layer, things like that. So all we do is we just need to take this user resolver and pass it in as a provider. And I'm just going to import that into my app.module.ts file, just like that. And now the last thing that we do need to do though is we need to specify this auto schema file property inside the GraphQL.forRoot options object. And this is because we need to actually have our auto-generated schema file. So this is just going to be a string, and it's going to be a relative path to where you want that file to be generated. I'll have it generated inside the source folder, and I'll just call this file GraphQL or schema GQL. And now see how a new file was created. Whoops. I'm gonna delete this. Okay. But now you see I have the schema.gql file, and you'll see that has some comments up here. This file was automatically generated. And you'll see that we have our type, and then we have the type query, and then it has our get user query. Very, very straightforward. And again, if you've used GraphQL before in a schema first approach where you actually used the schema definition language to write out your types and write out your queries, this is what it would look like. Okay. All right, cool. So now one thing that I do want to do, since our project now should not have any errors, because we do have one root query. Okay, so no errors so far. Let's actually go into the browser and let's take a look at our app. So let me move this over here. Okay, so right now my NestJS API is running on localhost port 3000. But what I want to show you all is the GraphQL Playground, which I'm sure some of you might be familiar with. But for those of you who are not, this is just basically a UI that you can access to test out your GraphQL server. You access it by just simply going to your localhost and then the port and then /GraphQL. And now you'll see this whole user interface right over here. And this was actually from a tutorial that I created earlier, but just ignore this part. And then you can see if I click on schema, I can now see the type, I see the user, I see all of its fields, and then I see the root query, and then I see get user query over there. Okay, so that's pretty cool, and you'll see how these exclamation marks, which you should know by now, that basically means the value is non-nullable. Remember how I set display name to be nullable? Notice how there's no exclamation mark next to it, next to the string keyword, because it means that display name is nullable. Okay, hopefully that makes sense, and you can see how that reflects. Okay, let's go ahead and execute this get user query because we have data that's being returned. Let's grab the ID, display name, and the username, and let's click play, and you can see now I get my data, and that's good. It's working great. Okay, so hopefully that is pretty straightforward. There you go, and that is how you can set up GraphQL in your project. We're not done yet, of course, but I just wanted to mention that it's just that easy. You first register the GraphQL module. Okay, then you create a GraphQL type. Okay, then you create the resolver, and then you register the resolver by passing it as a provider inside the app.module.ts. Okay, very, very, very straightforward. So now let's go ahead and play around with our resolver, with our queries, because we can be creative with this now. So what I'll do is I'll change this query to be get user by ID. I'll create a mock array of users. So let me create a new folder. I'll call this __mocks. Call this mock users.ts. And let me go back to, so let me paste that user over here. I'll do the same thing 2 more times. Let's change the ID up a little bit. And let's change the names. Let's do Jack. And let's do Peter. Or it should be lowercase Peter. Alright, so we have some users. So now that we have our query get user by ID, I'm going to show you how we can actually pass arguments in our query. Okay, so it's actually very easy. All you need to do is just use this args decorator, and this is going to be imported from the NestJS /GraphQL package. And then you're going to give your argument a name. You can call it whatever you want, but this decorator is for the translation. When it translates into GraphQL, it'll reflect the name based on this. Okay, and then now just give your argument name, whatever you want. This is just for the actual code itself. It doesn't have to be the same, but I'm just going to keep it the same for now. And remember, the ID is actually supposed to be a number. So let's do that. Let's set this to be a number. Okay, so we have ID set to a number, and now if I go into the schema file, you'll see right over here that something interesting happens. Well, yes, first we can see that the argument is there, but you see how it's a float. Okay, and this is actually really related to the issue that I told you about earlier, where if you don't have this type function set, it's going to pretty much like cast it to a float, and that's not what we want. Okay, so in this situation, what we can do inside the args decorator, as a second argument, I can pass in an object, and I can pass in this type property. And then this is going to be a function that just pretty much will return the same thing that we had returned right over here, int. So let's import that from NestJS GraphQL and return that. Okay. Now if I go back to my schema.graphql file, you'll see now it's actually an int and not a float. So that's very important. All right, so now whatever ID that we were to pass in from the GraphQL client, okay, is what will be the value of this ID in the code. So for example, if I go back into the GraphQL Playground, we no longer have this get user query anymore. If I click play, it's not going to work. If I look at the schema, you'll see that now we have this get user by ID, okay, and of course the ID is not nullable. So let's actually fix this up to change. Let's change it to get user by ID. And since we're passing an argument, we need to use parentheses. So I'm going to go ahead and specify the argument name, so ID, and then colon, and then I can pass in whatever value I want. That's a number, so I'll pass in 1. Obviously, this doesn't do anything right now because we need to change our logic to actually reflect searching for the user by its ID. Since we don't have a database set up yet, what I'll do is I will go ahead and import the mock users constant or the mock users array from the mock users file. And then I'll just simply call .find and I'll search for the user by its ID. So you can pretend like this is a database call or a call to the database. I'm going to go ahead and pass in this predicate function. And so this element is going to be the user itself, the current element in the array, and we want to check the ID. The user.id is equal to ID. So if this is true, it'll return the user. However, there's a situation where it might not even return the user at all. It might be null. So let's first do this. Let's click on play. Let's change it to 2. You can see I get a different user. Let's say if I put 5, you see how we get an error. So we need to make sure we are handling this accordingly, because this query itself right now is defined as it returns a non-nullable value. If you look at the schema, you see how it has this exclamation mark next to this return type user. That means it's returning a non-null value. But it could return a null value though. So what we need to do is we need to adjust this. So right over up top here, we can pass in query options, and then I can set nullable to be true. Okay. And now watch this. If I leave the query alone, because I don't have a user with ID 5, if I click play, you'll see that this query returns null. Okay. Pretty simple. Hopefully that makes sense. Now, one more thing that I do also want to mention before we move on is you can actually change the name of the query. Because right now this itself is the method name. Whatever the method name is going to be mapped into the actual schema file itself. Okay, and that's actually going to be what the query name they're going to need to use. If you want to change the name but keep the method name alone, inside the same object, the query options object, right over here, whoops. The query options object, you can pass in this name, and you can name this whatever you want. You can call a user by ID, for example. And then if you look right over here in the schema, it's now changed to user by ID. Okay, same thing in the file. It now shows user by ID. And you'll notice how the exclamation mark is no longer at the end of this user type because it's nullable now, okay? So hopefully that makes sense. I'm going to remove this name property though because I just want to leave it like this. All right, so let's move on. Let's create another query. Let's do a very simple one where we return an array of users. So we do need to provide this function right over here where we're indicating the return type. So we'll do this. Because we are returning an array of users this time, we need to actually use square bracket and then pass in the type that we're returning, like this. Not like this, where you have user and then square bracket. It's square bracket user, just like that. Okay, that will tell GraphQL that you are returning an array of users for this query. Okay, so now I'm going to create a method. I'll call this getUsers with an S at the end. And then what I'll do is I will simply, I don't think I'll need any arguments for now, but later on, if you want to get creative, you want to add arguments for filtering, you can. But we'll leave it alone for now. So I'll do return mock users just like that. Okay. And now if I go into schema file, you'll see I have this get users query right over here, and it returns an array of users, and it is non-nullable. So now if I were to, I think I might be able to use two queries over here. So let's do get users, and let's only grab the username only. Okay, so now you can see that I have my get users query being executed over here, as well as my get user by ID query. Okay, so let's remove this, and let's grab other values as well. Let's get the ID, and now I can see that I have an array of all of my users from our quote-unquote database, our fake database. Okay, so it's that easy. It's that easy. All right. Hopefully that makes sense. But now let's get into some more complicated stuff. So right now we have a type of user that has three values that are scalar values. We have number, string. Okay, we could have Boolean, but we don't. We'll leave that alone for now. But these are scalar values, okay? Kind of like primitive values. But what if we had a field that was a non-scalar value? What if it was like an object, like maybe the user class might have a settings field, and that settings field is of a custom type that we can create, like a user setting type, okay? And that user setting type will represent the settings for the user. Maybe you're building some kind of application and you want the user to be able to configure their settings for, let's say, mobile text, notifications, things like that. How would we ensure that we are resolving the user settings value for the corresponding user? Okay, and this is where it kind of starts to get tricky because it depends on the kind of database you're using. Because if you're using a non-relational database like MongoDB, then this is actually perfect because you don't have to even worry about relational stuff at all at the database level. You can let GraphQL take care of it for you. Because what GraphQL will do is it will call a resolver function to resolve the corresponding field to ensure that you are getting the correct data that is relevant to that user. So it kind of takes non-relational data and then it joins it all together to make it relational, if that makes sense. Okay, so I'll show you an example. So what we'll do first is we'll go ahead and create another type. So I'll go into my models and I'll create a new file, my models folder, and I'll create a new file. I'll call this usersetting.ts. And we're just going to do the same exact thing. We're going to import the same decorators. So let's do this export class userSetting. And then we will use the object type decorator. Okay, let's just import that. Whoops. from NestJS GraphQL. Okay, I have my object type. So let's go ahead and define a couple of fields. So we'll start off with we do need a user ID though, because keep in mind that in this situation, we do have a one-to-one relationship between the user and the user setting. Because, for example, a user should only have one user setting, and the user setting should only belong to one user. Okay, and furthermore, the user record can exist without the user setting, but the user setting cannot exist without the user. So let me repeat that again. So the user record in your database can exist without a user setting record associated with it. Okay, because maybe the user does not have a user setting. They can still use the application, but they just don't have settings set up yet. But the user setting record must have a user associated with, because you just can't have a user setting record sitting in your database with no user associated with it. That wouldn't really make any sense. Because in order for the user setting to be created in the first place, there has to be a user that was associated with it. Okay? So what we'll do is we will set up a user ID. This has to match the ID of the user as well. Okay? Oh, whoops, the type is not ID, but type is number. So let's go ahead and use the field decorator again. And we also do need to import the int constant. This is the GraphQL scalar type. And then we're going to call this decorator function and then pass in this type function or return type function, because we are dealing with a numeric data type. So I'll add some other fields as well. I'll do one for receive notifications. This will be Boolean value. I will set a default value for this. So default value will be false. Nullable false. But actually, I don't even need to include that, because by default, it will be non-nullable. Let me copy this. Let's do receive emails. Okay, and then, yeah, we'll leave it like this for now. Let's just keep it very simple. All right, now what I'm going to do is I'm going to go back into my user.ts file, the user model. And I'm going to go ahead and define another field for the user setting, which is going to map to this user setting type that I just created. So I'm going to create a property called settings, and this will have the type user setting just like that. And we're going to import that from user setting. And now what I'm going to do is I'm going to use the field decorator like this. And we do want settings to be nullable, because, like I said, there is a possibility that settings could be undefined because maybe the user did not set it up. Of course, this depends on how you set up your project. Sometimes you might just, populate the user settings field for them by default when they create their account. Sometimes you won't. So it's really up to how you want to set up your app. For now, I'll just leave it like this, where we do have the settings as nullable. So for our code itself, we will use the question mark operator, the optional operator. So that way TypeScript knows that settings is optional. For GraphQL, we do need to say that this field is nullable, just like this. Okay, nullable set to true. And if I were to go into my schema now, you'll see that it generated this user setting type. We have all three of our fields that are all non-nullable. We have, let's see, we have our type user. And notice how for settings, user setting is nullable because it doesn't have the exclamation mark next to it. All right, so everything's looking pretty good. We have no errors whatsoever, so that's good. If I go into the GraphQL Playground, the schema should recognize user setting. Great. Okay, if I were to try to get the settings value, of course, I need to make sure that I provide subfields for settings because it is an object. And this is where you need to also understand how GraphQL works when it comes to fields that are non-scalars, or in other words, that are objects that have other subfields, like this one. So basically, it's kind of like a recursive process where GraphQL will keep on. It's a process called resolve chaining, where it will look for a field if it's an object that needs its fields to be populated with the correct data, then it will populate that data. Okay. So for example, inside settings, we only have user ID, we have receive emails and receive notifications. But what if settings also had a field that was mapped to a custom type? Kind of like how user is mapped to user settings. User settings might be mapped to a more sophisticated object as well. So maybe we might have, I don't know, I'm just gonna make something up. Maybe let's pretend like notifications is its own field and it is an object, and it kind of just goes down this hierarchy. So it'll chain all of these resolvers, and it'll retrieve all of the necessary data it needs to populate each corresponding object. Okay, so let me just remove this. So in this case right now, what will happen is when we use the get users query, it will get all of these scalar values, ID and username. It sees settings. Settings is not a scalar value. It maps to an object. And what we need to do is get all of the necessary data, so user ID, receive emails, and receive notifications, and populate those fields so that way when we return it back to the client, they get those fields. Okay, hopefully that makes sense. But it's pretty much like a recursive process where it'll keep going down that hierarchy until there are no more objects, until it pretty much bottoms out at scalar values. So there's no more objects left to resolve, then it'll just stop. Okay, so if I click play, you'll see that now I get a list of all the users, but notice how all of the settings are null. That's because we don't have any settings that are associated with these users, and we also did not resolve the settings field. So now I'm going to show you how we can actually populate this settings field. Okay, so what we'll do now is this. We will go ahead and go into, we'll first create some mock data for the user settings, mock user settings.ts. Okay, and then let's create the variable, and we want to make sure we map our data accordingly. So we need user ID, receive notifications, and receive emails. So let's do this. User ID 1, receive notifications, false, receive emails, false. Okay, so pretend this user settings data is its own database table or its own database collection if you're using something like MongoDB. For now, I'll just have only 2 user setting objects, so I'll set the ID 1 and 3, and we'll change up the values a little bit. All right, so we have our mock user settings. Now let's go ahead and actually resolve this data with the correct user. So notice how that we have only 2 objects. So this will imply that the user ID of 1 will correspond with this user settings right over here. Okay, and same thing with user ID of 3. Now, it's of course it's also up to you when you are writing your application that your user and user setting IDs are going to be consistent with each other. You need to make sure that as you are creating your records, that when you have a user and then you create a user setting for them, that the user ID is going to reference the correct, the user settings user ID field is going to reference the correct user ID itself. That's the way how you can know that this user setting belongs to this user. Okay, so what we're going to do now is we're going to go back into the user resolver.ts file where we have our user resolver class, and we're going to go ahead and create a method that is going to be responsible for resolving the field for settings. So what we're going to do is we're going to let's call this get settings or get user settings. Okay, and then what I'm going to do is I'm simply going to go ahead and first use a decorator. This decorator is going to be the resolve field decorator. Let me import that from NestJS GraphQL package. And then I'm going to annotate this getUserSettings function with the resolve field decorator. Okay, so now what I want to do is first I want to actually specify what it is returning. So we can use this, we can pass in this callback function, and we are not returning an array, but we're returning the user settings, which is just a single object. So we're just going to reference that user model, that user setting model. Okay, and that's imported from up here. All right, so now here's another thing that we need to also do. Inside this get user settings method, we actually need to make sure we know which user setting to get. And remember how I said earlier, we need to make sure that we have some unique value that is going to correspond between the user setting and the user itself. So we need to first actually know, one, which user we are trying to resolve the data for. But how would we get access to that user though? Okay, because for example, we have a bunch of different users. We have 3 users in this case. We want to make sure that we are resolving the settings property for this user, and this user. But how do we actually get access to that user's data? Because we have the ID for that user, and that's the way that we can use, that's the data that we can use to actually get the user settings. How do we get access to that? So what we can do though is there's actually this decorator called parent, and we're going to import that from the NestJS GraphQL package. Okay, so I can use this @parent decorator, and this actually gives me access to the parent of this field, of this settings field. And it makes sense because if you think about it, we have this user setting property right over here. It has a parent. It has the user as its parent. Remember how earlier I said that user by itself can exist without a user setting record. However, user setting cannot exist without the user record. It's kind of like a parent to child relationship. Okay, think of it like this: the parent alone can exist without the kid, but the kid alone cannot exist without the parent. You know, assuming it's a baby, of course, the baby would need a parent to take care of it, obviously. So it's kind of like that analogy. Hopefully, it's not the best analogy, but hopefully it makes sense. Okay, but that's really what's going on here. That's actually a common analogy that many people refer to when they talk about these types of relationships. You have a parent to child relationship where the parent can exist without the child, but the child cannot exist without the parent. And that's this exact situation right over here. Okay, so in this situation, we can get the parent by using the parent decorator. And then I'll just call this user. And let me make sure my user model is imported. So this is the argument name of the parent. So this right over here gives us the access. It gives us access to the parent of the field, of the settings field. Okay, so that way it will know which parent to actually use to query for the correct user settings. Now, before we do anything else, though, we do also need to pass in this optional value, but it's no longer optional because we're trying to resolve a field. Okay, so we need to actually pass in this function, and we need to return whatever the parent is. So that's going to be user, the user model itself. This basically tells the resolver that user is the parent. Okay, so you need to do this if you are using this resolve field right over here. Okay, because user setting has a parent, which is user. So hopefully that all makes sense. So now let's actually, before I do anything else though, I'll just actually console log user just to show you what actually happens in the logs when I try to query get users, and then we try to get the settings resolved. If I click play, you'll see in the console, let's see, refresh. Seems like nothing is actually being logged. I think we actually do need to return something. So let's just do this. Let's return an empty object for now. Seems like nothing is working in that case. Not sure what. Oh, you know what it is. Hold on. Yeah, I need to do one more thing. So you notice how right over here in the user type, I have settings and I have get user settings. I actually don't want this part right over here, because actually, if you see right over here, it's going to expect me to do get user settings in order to get the actual user settings. So if I do that, you'll notice that. Let me show you. See, now it's saying cannot return null or non-nullable field, but you'll see now the logs are occurring right over here. But of course, I don't want two of these things to do the same thing. And the reason why this is happening is because I have this method name right over here as get user settings, and it'll actually generate that as its own field right over here. But I don't want that though, so what I can do is I can actually pass in an argument or an object, and I can set the name to just be settings, so that way it'll match this settings right over here, and you can see now that method name is gone. So this allows me to actually keep the same name while also keeping a different method. Hopefully that part makes sense. So now let me get rid of this, and if I call settings, now you're going to see I get an error. This is cannot return null, which of course this makes sense because we are returning an empty object, but I wanted you all to see the logs right over here. You can see that all of the objects are being logged. These are all of the parents for the user setting field. Okay, so each parent of course is going to have its ID. So I can reference the ID to find the correct user setting for that user. So that's what we're going to do. What we're going to do is we're going to reference mock user settings, and all I'm going to do is just call .find, and we imported it up top over here. So we imported mock user settings. We're going to call .find, and I'm going to search for a setting where the setting.userid is equal to user.id. Okay, let me remove the console log. Now, of course, this is also going to error out if it returns a null value. So we do need to actually make sure that this query is returning a nullable value. Right now, you can see that settings expects a non-nullable value. So we do need to change that. And what we need to do inside this resolve field, inside this object, we just simply pass in nullable and set it to true. And then when you look at the schema, you can see now user setting no longer has the exclamation mark. You have to also make sure you do it for this as well. Okay. Well, actually, maybe you might not need to. I'm not too sure. If I remove that, yeah, actually, you don't need to worry about this part because the resolve field is what is actually taking care of it for you. But I'll just leave it like that for now, just because it doesn't really affect it much, anyways. Okay. But now that user setting is no longer a non-nullable value, so it can be nullable. So since .find will by default return an undefined value if it cannot find the corresponding user setting, or if this predicate fails, then it will return undefined, which will resolve to null, and GraphQL will take care of that for us. So now if I click play, notice how now I don't get any errors, but you'll see that for the user ID of 1, I get the correct settings. For user ID 2, I have no settings because I don't have any settings for user ID of 2. But for user ID 3, I do. Okay, so hopefully that part makes sense. So now this is how it resolves the data. Okay, you get access to the parent. You figure out what unique value you need from the parent to query the data from your database to get the corresponding field that relates to the actual parent data itself. In this case, we want to figure out which user setting relates to our corresponding user. Okay, so hopefully all of this stuff makes sense. Now, I do also want to mention one thing though. Right now, let's pretend that we have a database connection. Let's say we're not using any mock data at all. Okay. If you were to actually take a look at this, right? Because the order of operations is pretty straightforward. We call get users, or actually we're not using get user by the way, we're calling get users. Okay, so we're using the get users query. So it goes over here first, and then since it needs to resolve the user settings field, it will go down over here. Okay, so this right over here alone is a database call. Okay, we're calling a database and returning the data. This right over here inside this get user settings method, this return mock user settings.find would also be another database call. Okay, so in this implementation, you actually would be calling the database twice, and then you would be joining the data all together and sending it back to the client. Now you can start to see it being a problem when you have a bunch of different fields that are objects that need to be resolved with its correct data. Because let's say if you had 5 different fields, you can start to imagine that that's going to be 5 different database calls that you're going to need to make to the database to actually get the corresponding data and then join it together with just everything. Okay. And of course that becomes a problem because that can slow down your application. And it's not like, the ideal solution if you're trying to really save on read and writes. Now, the other thing that I also want to mention is this is one thing that GraphQL solves is it allows you to take something that is non-relational from the database standpoint and make it relational. Okay, so it's not necessarily a huge thing that's bad. There are trade-offs. Okay, there's pros and cons with using GraphQL, and this is one thing that I want you all to be aware of. Now, let's say if we were using a relational database. Okay, you can still actually use GraphQL with a relational database like SQL. Because, for example, SQL databases take care of the relational data at the database level. But here's the part that is interesting, though, because if you're using a SQL database, let's say we're using MySQL, and let's say we're using an ORM like TypeORM, which is very popular. TypeORM has tools where you can actually query a record from the database, and you can also query all of its relations, all of its one-to-one relations, all of its one-to-many relations, and a bunch of different relations. Okay, and all of that is done with one single query because the ORM takes care of all of that for you. You don't have to write any custom query yourself. You don't have to make 2 different queries. The ORM does it for you, and that actually is a lot better because instead of having a bunch of different queries to the database, you have one single query that is made and it gives you everything that you need. So I will say though, in my opinion, if you are using a relational database like MySQL or Postgres and you still want to use GraphQL, you can. The only difference is that you probably won't need to worry about using the resolve field because the resolve field is, from my opinion and from what we're observing, we can clearly see that the resolve field is really used to retrieve value that is not necessarily associated directly with the record. Like it's not able to be retrieved immediately in one go. That makes sense. Okay, because let's say if I were using a SQL database, I already have one way to get all the data using one query by using the built-in TypeORM methods. Why would I want to call another query to get all the settings? Because in a relational database, you can simply just write a query that gets you the user with its user settings in one single query. In MongoDB, it is a little bit more complicated. It's not as straightforward as SQL, but again, with GraphQL, you can kind of like bridge that gap of having relational without needing to worry about your database being relational. Okay, so like I said, in my opinion, I think that if we were to use GraphQL with a relational database, that would be totally fine. I would just avoid using the resolve field, and I would just write regular queries that return the data. The client side would still be able to retrieve whatever it needs to retrieve. It's just that the server will return back whatever you asked for. So you'll still avoid the problem of overfetching. Okay, it's just that you'll be able to get all the data that you need and then get what you actually ask for. And like I said, when we actually see an example of how to use this with a database, you'll start to understand. All right, so now I'm going to show you all how we can actually create data using GraphQL. Okay, so many of you are used to or familiar with REST APIs, and creating data, you would use a post request and send a request body. In GraphQL, there are no post requests. There are what's called mutations. And mutations are really just a way for you to really mutate data, hence the name mutation. So you can use it to create data, you can use it to update data, all that good stuff. So what I'll do is I'll show you an example of how we can create a user. So all it will literally do is it will take the user data and then add it to our mock users array in memory. So when we query the users again, we'll see the updated mock users. Okay, so let's do this. Let's go ahead into the user resolver because we are creating users, so it should be related to the user resolver itself. And we're going to create a method, and I'll call this create user. And then we need to actually tell GraphQL that, hey, this is going to be a mutation. So we're going to import the mutation decorator up top over here. And then I'm going to apply that decorator. I'm going to annotate this create user method with the mutation decorator, just like that. We also want to specify what the return value is when we create the user. So inside this mutation decorator as an argument, I'm going to pass returns, and then we're going to return user. Okay. All right. So now what we want to be able to do is we want to be able to actually take in arguments. So for example, I'll show you a really quick example using the same function on how you can take in a single argument. And then I'll show you a more practical case for our situation. So for example, when we want to create a user, we need a couple of information. We need the username, we need display name. You might have other fields that you'll need, but username and display name are the most common one. Of course, you typically don't create or you don't send an ID when you create a user. You let the database generate it. But in this case, what I'll do is I will set a counter, incremental ID. I'll set this to 3, and I'll increment it each time. Or let me see. I kind of need this to be global, so that's not going to work. I just want to show a really easy example. So here's what I'll do. I guess what I'll do is I'll generate, or not generate, I will create it inside this file. Incremental ID equals 3. Again, not the most practical solution, but this is just for just a simple example because we don't have a database. Okay, so what I'll do is I will use the args decorator, and then I want the username. So username will be a string, and I want the display name, but display name could be nullable, so I don't even need it, but I will provide it as well. Display name string, and then since display name is in fact nullable, I will pass in this second argument into this second args order here for display name, and I'll say that it is nullable, so I'll set that to true. Okay, so now we have two arguments, username and display name, and we'll increment the incremental ID from 3 to 4 and etc. whenever we create a new user. So here's what I'll do. Const new user, I'll create a new variable. I will go ahead and grab the username and display name fields, and then the ID, I'll set that to ++ incremental ID. So this will be a prefix incremental operator. So that'll increment the ID to, or that'll increment this variable from 3 to 4 and then assign it to ID. And then what I'm going to do is I want to add that user to this mock users array. So I'll just do mock users dot push new user, and then we will just simply return new user. And let's go ahead and see what this looks like. Okay, first let's verify there are no errors. Good. Our logs are good. Let's go back into the GraphQL Playground. If I go into the schema, you can see that I now have this type mutation, and then I have this create user mutation. And this create user mutation has two arguments. It has a username, which is a non-nullable, and then has display name, which is nullable, and then it returns user, which of course is a non-nullable value. So what I'll do is I'll create a new tab inside this GraphQL Playground, and I'll use the mutation keyword instead of the query keyword because I want to perform a mutation. And I'm going to go ahead and use the create user mutation, and this is going to be very simple. All I do is I simply provide the necessary arguments that I need. So I need username. So I'll set this to be, let's do Duncan. And then let's do display name, which is optional, but we'll provide one. Duncan. Okay. And of course, we can provide a pair of curly braces because remember, create user, even though it's a mutation, it still also returns a value. Remember that. So we can also specify what fields that we want to grab from that return value because it's an object. So I can grab the ID, I can grab the username, display name, anything that is within the user. I can also grab the user settings as well, even though this user will not have user settings. So if I click play, look at what happens. Let's see. Oh, I'm sorry, I forgot to provide the subfields for settings. Let's do user ID, receive emails, and receive notifications. So now look at this. I just created the user, and then you can see that I have the ID of 4, username Duncan, display name Duncan, settings null. Okay, of course that's pretty obvious because we just created this user, and in the mock user settings we don't have a corresponding user settings for that user. Okay, but of course we can create a user settings, but I'll do that in just a little bit. Hopefully this makes sense. What we just did was we provided two arguments to create the user. Now, of course, while you can use these as args, like you can use the args decorator, you don't want to actually do it this way because let's say if you had so many arguments that you need to pass in to this mutation, you're going to have a long list of arguments being passed in, and it's just not going to look nice in your code. So what I would recommend you do is instead of using args, you use what's called an input type. Okay, and that is basically kind of like a way how you can set up a request body, if that makes sense. It allows you to set up like an object that has all of the fields that are necessary for creating the user. So I'll show you how to do that. It's actually pretty simple. So what I'll do is, let's see, I will go into I don't really know where to put this, but I'll create a new folder inside GraphQL. I'll call this utils for now. And then I'll create a new file and I'll call this, let's see, create user input.ts. So since we're using the code first approach inside this file, we will create a class and I'll call this create user input. Okay. And then we're going to use the input type decorator. So I'll import that up top over here from NestJS at NestJS/GraphQL. Okay. And then I'll annotate this class with the input type decorator, just like this. And now we're going to define the fields that will belong to this input. So this will just be, again, similar to when you're making a post request, you have your fields. This will just be similar to that for a mutation. So for a mutation, we expect two arguments, username and display name. So let's set up the username first. So username, be string, and we're going to use the field decorator. So let's import that like this. Remember, username is non-nullable. Okay, but display name is nullable. So what I'll do is I'll annotate display name, but I'll also pass in an object, and I'll provide the property nullable and set that to true. And if we had any other fields that we needed to create the user, we can add them over here. So now this makes it more cleaner. So instead of having to use a bunch of different arguments and make it look really ugly, we can use a simple input type to provide all of our values. Okay, so now what we can do is we can first remove these two args, or these two arguments, and then we'll still use the args decorator though, but we'll call this create user data, and then we'll name the argument variable, or the argument name, create user data, and the type will be we'll use the create user input class to annotate this argument right over here. Okay, and let's import that up top there so that gets imported right over here. All right, perfect. So now we actually have to use this data to create the user. So what I'll do is I will actually destructure the values from this argument. So I can just do that by simply kind of like using the bracket, curly brace notation. So I can either do that inside the argument signature like this. So I can do username and display name like that. Or if you don't like doing that, you can just simply do this const create user data, username, display name. Doesn't matter, it's up to you how you want to do it, but it still yields the same result. Okay, now let's go back to our GraphQL Playground. Let's refresh. Okay, if I look at the schema now, you'll see that we now have an input. So we had type, and now we have input, create user input. And if you look at the mutation, it is now one single argument, but it is this create user input type. So now what we'll do is let's remove all this stuff right over here, and let's call create user. Okay, and now you'll see that it has this create user data right over here. So instead of passing individual arguments one by one, we can just put that all in an object. So we have create user data, which is the name of our input, or name of the argument, and this is going to be an object. So we'll use a pair of curly braces, and then we just provide the property name that we need to provide, which is username. Let's do Duncan, and then display name, Duncan as well. And then when we receive the return value, let's go ahead and get the ID, username, and display name. So if I click play, you'll see now we have the same result. Okay, create user returns ID of 4, username, and display name. All right, pretty straightforward. Hopefully that makes sense. Okay. All right, so let's do another example of a mutation. So this time we'll set up a mutation to create the user settings. So here's what we'll do. We're going to create another resolver. So we'll go into the resolvers folder inside GraphQL. We'll create a user setting resolver. And this resolver will take care of queries specifically for user settings, not user, but user settings alone. Okay. So let's export class user settings resolver. So we're going to create a class, call it user settings resolver. Let's use the resolver decorator as well. Let's import that up top here from NestJS GraphQL. All right, and next, what we're going to do is we'll set up a mutation. So let's also import the mutation decorator as well. And we'll create a method, and we'll call it create user settings. And then I'll decorate this method with the mutation decorator. And we're going to explicitly say what it's going to return, and it's going to return user settings. So we need to make sure we import that user setting model, that user setting type. Okay, and that comes from this right over here. We import this into the user setting resolver file, and we specify that this is the return value. All right, so now we're just going to do the same thing that we did with the user when we created it. Okay, so we're going to go ahead and create another input type to take care of creating the user settings. So let's create a new file. Let's call it create user settings input.ts. And I'll just copy this part. So I'll create a class. And then I'll use the input type decorator. And then now for the fields, we need, let's see, we need user ID, receive notifications, and receive emails. Because yes, in this case, you will expect the user ID because let's say, for example, the user does not have any user settings. But let's say if they do configure the settings, then you want to make sure when you create it that you have the correct user ID. In realistic scenarios, you'll pass the user ID from the front end client back to the back end, the GraphQL server. So that way it'll know who the user ID, who the user setting is for. Okay, so we will need all three of these values. So let's do this. I pretty much just copied and pasted it because it's just pretty much the same thing. The only difference is that we will not want default value. We do want this type returning int, so let's import int up top over there. However, for these two properties, we definitely do want nullable to be true. Right over here. And the reason why is actually because we actually don't know. Well, actually, for creating the user, you definitely do want a default value because this is creating. It's actually different than updating because we're actually trying to just create the record. Okay, so we do want a default value set to false. Okay. But yeah, creating is different than updating. With updating, you do want nullable to be true for the fields, but you don't want a default value because that would override any existing fields that you don't want to actually change at all. Okay, but for the user ID, yes, this has to be mandatory because you can't create the record without the user ID. All right, so I think we have a pretty good solution here. So let's kind of like close this out. And now what we're going to do is we're going to use the args decorator. Let's import that up top here. Now let's do create user settings data. And then let's go ahead and annotate the type to be, create user settings inputs. Okay. All right. So now all we really need to do next is just take this create user settings data and just add it to this array because we're going to have user ID, receive notifications, and receive emails already. Because the front end, in order to create the settings, you need to already know who you're creating the settings for. So the ID is always going to be required when you're calling this mutation, which from the front end side, let's say if we had authentication, the front end side would have access to the user context. They would know what the user ID is, so they can use that to pass it in when they perform the mutation. So let's just simply take create user settings data. I will console log it just so we can see what it looks like, but I will go ahead and reference user mock user settings push and then pass in create user settings data, and then we'll just return create user settings data, because that's the return value. And then now we need to, of course, register our resolver. We need to register our user settings resolver. So we're going to go inside app.module.ts, and then we'll just do the same thing we did with user resolver and pass in user settings resolver, just like that. Verify that there are no errors in the console. Okay, good. Let's go back into our GraphQL Playground. Let's create a new tab, and let's look at the schema. You can see that we now have, let's see, the create user settings input, and we have 2 mutations now. So let's create a mutation. We'll do create user settings. Oops. So create user settings data. So we need the user ID, of course. Now, one thing that we aren't checking is if the user ID exists. So that's obviously a problem. But since we do actually have 3 users, and one of our users, user ID number 2, does not have settings, so we'll just use user ID 2. So this actually works out great for us. So user ID 2, receive emails. Well, actually, since these 2 values are nullable, let's actually see what happens if I omit them. So let's get back to user ID, receive emails, and receive notifications. So if I click play, okay, perfect. So notice how when I create the user settings, user ID 2 is right over here, receive emails is false, and receive notifications is false. So that's good. Of course, I can't make this mutation again. Otherwise, it's going to just add this same record into the array, and we're not doing any unique checks. Okay, but what I will do though is let me actually restart my server, and let me just show you what happens if I set receive emails to true. Okay, because you can see that there is a default value that I think it appears right over here, or maybe it'll tell you right over here. Yeah, so right over here, input create user settings input, receive notifications. It's not required, so it doesn't have that exclamation mark. And then you can see right over here, boolean equals false. So that's the default value. So that's good. Okay. So let's say if I set receive emails to true, but I don't set receive notifications, and if I click play, you'll see now it's receive emails true, receive notifications false. So that's perfect. Now if I go back to the get users tab, and if I were to click play, now all of my users have settings. You can see now the user of ID number 2 that I just create the settings for has user settings. So that's perfect. So that's how you can create a mutation for this situation. All right, so the last thing that I'll do for you all is show you how you can integrate a SQL server with TypeORM as the object relational mapper with GraphQL. Okay, so of course, make sure you have a SQL server already installed on your computer. If you have Docker, you can just simply set one up with Docker. It's actually very easy, and you don't even need to install a SQL server. You can use whatever you want by just pulling down the Docker image and running it as a container. I'll be using MySQL though, but if you use something like Postgres or MariaDB or something else that is SQL related, you just need to make sure you install the correct SQL driver. Okay, so what I'll do is I'll install a couple dependencies in the project. So I'll install @NestJS/TypeORM. So that's the TypeORM wrapper. That's the NestJS TypeORM wrapper. We need the actual TypeORM package, and then since we're using MySQL, we're going to install MySQL 2. Okay, and that should be it for that. Okay, of course, if you're using Postgres, you just need to make sure you install the correct Postgres driver. You can easily find that off of Google, so I'd encourage you to look that up. Just simply search Postgres Node.js driver, and then you'll find a bunch of different solutions that will work. Though the documentation on NestJS should have it somewhere. Okay, so let's go ahead and install these packages. Once we're done, we're going to configure our app module to register the TypeORM module. So that will take care of initializing the connection to the database, and as well as a bunch of other stuff. So let's just wait for that to happen. Shouldn't take too long. There we go. Let's go back to our code, and what we're going to do, we're going to go into app.module.ts, and I'm going to go ahead and import, let's see, we want to import TypeORM module from TypeORM. Now let me actually move this up top, right over here. So we're going to register the TypeORM module. So we're going to reference TypeORM module, and then we're going to call for root. And this is where we're going to pass in our database configuration. Now, normally I would encourage you to put this in an environment variable, but just for the sake of this tutorial, I'm just going to hard code all of my values over here. But like I said, for an actual application that you're building, definitely use environment variables. So I'm using MySQL. So for the type, I'm going to set this to MySQL. The host is going to, of course, be localhost because I'm running this locally. I'm running my database locally. The port, by default, it's 3306, and that's actually the port that my SQL server is running on. The username for my database is test_user. Password is test_user. For database, I think, if I remember correctly, you do need to create the database manually, and then TypeORM can then initialize it. I don't remember entirely, but if that's the case, then we can just do that. I'll just set this to GraphQL tutorial, or GraphQL_tutorial. And then we do need entities, so let's set that up. That's going to be an array of entities. And we'll set synchronize to true. If you're using TypeORM for production, do not set this to true. Set this to false. This is only good for development. But what this will do is it will actually synchronize your database based on the updates of your entities. Okay, so I can see that I am getting errors in my console, which is good because it at least gives us feedback. Seems like it says access denied. Yeah, unable to connect to the database. I think it's because, well, I don't know if it's because the database does not exist, but what I'll do is I'll create the database. So let's do create database GraphQL tutorial, and then that should be fine. So let's see if that fixed it. Oh, I'm sorry, I forgot that my password is actually test_user123. Okay, there we go. Okay, so let me actually, I'm just out of curiosity, let me do this drop database tutorial. I think if I do that, it will not create the database for me automatically. Should give me an error, I think. Yeah, so you do need to make sure you create the database ahead of time before actually running your project, because you can see right over here it errors out and says unknown database. Okay, so yeah, the first error that I had was I put the wrong password. But to verify, yes, you do need to create the database first. Now our connection works, so we're good to go. All right, so now here's the other part that we do need to do, of course. We do need to set up entities, okay? And if you have used TypeORM before, then this should be very easy for you. But here's the problem, though. The question that you might be asking is, do we need to create a brand new class for our TypeORM entity to represent the data from the database? And the answer to that question should be no, because your data in the database should actually be very, very, if not 100% identical to your GraphQL data as well. So you see over here, you have data for user, okay? All of this data over here that you're using to model your GraphQL response should actually also reflect your database as well. In rare cases, you could create separate entities, but you don't need to, because it's just going to be very redundant and it's going to be hard to maintain, because if you change one thing on one side, let's say if you change one thing for the TypeORM entity, you're going to have to change it for the GraphQL model as well. and it just becomes annoying. So here's what I'll show you how you can actually use one single class for both TypeORM and GraphQL. Okay, here's what we'll do. What we're going to do is we're going to use the same class, but the nice thing is, though, we can actually use different decorators from different packages, from the TypeORM package specifically, and using those additional decorators, we can add additional metadata to these properties, so that way it will be used for the context of TypeORM. So I'll show you an example. So right over here up top in the user.ts file, I'll go ahead and then I'll import entity column primary generated column from TypeORM. Okay, so to tell TypeORM that this class is going to be an TypeORM entity, we need to use the entity decorator. I'll set the name to be users, like this. Okay. To tell TypeORM that you have an ID that's going to be auto-generated, you're going to use the primary generated column. So I'll do that up top here. And yes, you can use multiple decorators for a field. Okay. So we have primary generated column right over here. And then for the rest of our fields, we also want TypeORM to know that these are also going to be columns as well. So I'll use the column decorator that is from TypeORM. And this should have no effect with our GraphQL server at all. Okay, everything will still work just fine. So you'll see that right over here, I can still query my users. If I refresh, let me refresh the GraphQL server. I can still query everything. I can still create a user. I can still create user settings. Everything works just fine. Okay, all we're doing is we're just reusing this class and providing metadata for the class, and that's really it. TypeORM is going to ignore the other decorators because it doesn't apply to it. Okay. So now let's go ahead and do this. Let's import this user entity into this entities array. So that's just this user class. It's going to be imported from this GraphQL models user.ts file. Okay, it's going to be input up here, and we're providing it as an entity for TypeORM. Okay. So now we do get an error, of course, because we need to do the same thing for user settings, because remember how I said earlier in the tutorial that user and user settings pretty much have a one-to-one relationship. Okay, so we need to do the same thing for user settings. So what we're going to do is import those same decorators from TypeORM. So we need primary, well actually we won't need primary generated column though, I think, for user setting, mainly because that is going to be set and not auto generated, but it will be a primary column though instead of a primary generated column. Column entity. So we'll set this, and I'll set the name to user settings. So user ID will be primary column, not primary generated column, because we're not going to be doing any auto generating of the ID. It's just that whenever we create the user, we don't have the user setting created just yet. But then when we do create the user setting, we are manually setting the user ID. Okay. So let's set the column right over here for these two. Okay, and now we'll import user settings. Let's see, entities right over here, user settings, user setting. Okay, and let's see what happens. Okay. Now it says data type user setting in user.settings not supported. Okay, the other problem here is that we need to actually tell TypeORM that this is a one-to-one relationship, and that's actually pretty easy. So I'll show you how to do that. So do is right over here in the user.ts file, we want to say, hey, look, this settings property, the settings field, is a one-to-one relation. So what we can do is we can use the one-to-one decorator that comes from TypeORM to denote that. Okay, so let's see, right over here from TypeORM, we're gonna import 1 to 1. And then what we're going to do is, since this user object is the parent, we're going to do a couple things. Well, actually, I'm sorry, we actually don't need to have the column field for that. Sorry, it's been a while since I've used TypeORM, so I do apologize for that. So I'm going to remove this column decorator on the settings, and I'm going to set this to 1 to 1 instead. And this will have a callback function that will, let's see, this is user, so we need to pass in user setting right over here. And then right underneath, we're going to use the join column decorator from TypeORM. So I'm going to import that up top over here. So what this will do is when you actually query your data, you'll actually be able to reference the settings part in TypeORM. Okay, and now watch this. We have no more errors. Look how beautiful that is. No more errors. Okay, but none of the things that we just did with TypeORM to our class will affect our GraphQL stuff at all. Okay, so and that's great. Like I said, and that's the beauty of decorators. Okay, that's the beauty of decorators. Is TypeORM will interpret this class and it'll read whatever decorators it needs to read, and it'll ignore what it doesn't. Like for example, TypeORM doesn't recognize this object type decorator. It has nothing to do with it, so it's going to ignore it. Okay, it's really just looking for specific metadata that it needs to map the class appropriately to the database table. There will be an issue though if, let's say, if the metadata does overlap, but I don't think that will happen in this case. Okay, all right, so we have our first two entities set up. Let's go into our SQL Server and let me show you what our schema looks like. So if I do, I think describe GraphQL tutorial. No, I have to go to use GraphQL tutorial. Show tables. And now you see how I have two tables. I have one table for users and one table for user settings. Great. So we can actually persist data to the database. So let's actually do that. So we can actually get rid of our mock data right over here. We'll leave it alone because we might write some tests later on. But we don't need to worry about using that anymore because we have a database. So what we'll do is first, let's actually do this. Let's modify our user resolver to actually hit the actual database. Okay, so we actually get the actual data from the database itself, not from the mock array. Let's do the easiest case first, which is get users. Okay, so in NestJS, there's a pattern that they encourage you to follow, and that's the controller service repository layer. In this case, we don't have controllers because controllers are for REST endpoints. We have GraphQL, so we can ignore the controller part and instead just have a service layer. The service layer is primarily responsible for performing business logic, and it's also typically responsible for interacting with the data access layer, which is the repository layer. So in this case, it would be responsible for interacting with the TypeORM database as well. Okay, so just to keep things organized, because I didn't create any modules at all for our project, so what I'll do is I'll create a quick user module. So we'll do this users, and I'll create a users.module.ts file. Okay, and then what I'm going to do is I'm going to create a class called users module, just like that. And then to tell NestJS that a class is a module, you use the module decorator, and that comes from NestJS common. And then you want to have any imports, any controllers. In this case, we don't, so we don't need that. We do possibly have providers, and I think that's really it. Imports, control, yeah, imports and providers are going to be the main thing. Okay. So what I'll do is I'll also move the user resolver and maybe even the user settings resolver into it. Typically though, you want to keep each module, containing its own related business logic. So in this case, user settings is actually kind of different logic than user itself. Some can say that they are related to each other, but in this case, since they are separate, you know, like I said, we're not going to make things super complicated. So for now, what I'll do is I'll just move the user resolver into users module right over here. What I'm going to do next is inside the app.module.ts, instead of adding this user resolver as a provider, I'm just going to remove that for now. And I'm going to remove this import up top here. Because what we're going to do is we're going to actually add the provider. We're going to add the user resolver as a provider for the users module, just like this. So user resolver. So now the users module has everything related to user business logic. Okay. And then what we're going to do is we're going to take the users module and then add that as an import inside our root app module right over here. So what this will do is it'll basically take all of its imports and providers over here and then kind of like resolve it inside the root module itself. So this is a way to kind of keep things organized. So you don't want, because you don't want everything all in one single module. You want to, be able to kind of like separate it, because it also allows reusability as well. So this is kind of like a good way to separate concerns, and it's good practice as well. So that's why I'm doing it, just to show you all. Okay, so now you'll notice we actually don't have any more errors anymore, because right now user module has the user resolver as a provider, and app module imported users module. So if I go back to my GraphQL Playground, I have no issues with using any of these queries. It's almost as if like nothing happened. Okay, so now the next thing that I'm going to do is I'm going to set up a user service. So I'm going to go ahead and call this user service.ts. Okay, actually, yeah, I'll leave it like this for now. What I'll do is I'll create a class and I'll call this user service. And then I'm going to go ahead and use this injectable decorator, because this tells NestJS that this is going to be a provider. Okay, and it also ensures that when it creates the instance, it creates a singleton of it, and then it'll take care of all of the dependency injection, because that's what NestJS does underneath the hood. It actually uses dependency injection to resolve dependencies, so that way it doesn't create multiple instances of the user service. Okay. Additionally, though, if you want to, you can create an interface and define all of those abstract methods. I'm not going to do that, just to save some time and avoid making things super complicated. But I do encourage you to do that, so that way you're following good programming practice and what NestJS encourages. So what I'm going to do here is I'm going to go ahead and set up a constructor. And remember how I said earlier, the user service is responsible for interacting with not only performing business logic, but also interacting with the data layer. So this is where we're actually going to be able to talk to our database using TypeORM. So to do that, we actually need to use what's called a repository. Okay, and we're going to use this inject repository decorator, which for some reason it's not recognizing it in my TypeScript code, but I can just import that, inject repository, and this should come from NestJS TypeORM, I believe. Yep, perfect. Okay, and so what this will do is this will take care of injecting the correct repository for the entity that you're trying to work with. So if I'm trying to get all users, then I'm going to inject the user repository. So I'm going to do this. I'm going to pass in the entity. So this is the same entity that we are using for GraphQL and TypeORM, the same class right over here. So we're going to pass that in, and we need to make sure we import that. So the next thing that we'll do is we need to actually, of course, give the argument a name. So I'll do private users repository. And I'll type annotate this to repository user, like that. I do need to import repository from TypeORM. Or actually, I think it comes from, it might actually come from TypeORM. I'm not too, I don't remember. Yes, it does come from TypeORM. Just double checked. There we go. Okay. So now what we can do is we can actually interact with this user repository. We can call methods on the user repository to retrieve whatever data we need. But before we can do anything though, we need to actually first make sure that we are providing this user right over here. All right, so now before we can even use this user repository right over here, we need to first of all provide our user service inside the users module. So we're going to do that. So let's import user service class, and then that's going to be added as a provider. Now you're going to see that if you look at the console logs right over here, we're going to get an error, and that's okay because there's still another step that we need to do before we can actually use the user repository. Okay, you'll see that right over here it's complaining about if user repository is a provider, is it part of the current users module? Okay, so whenever you need to use an entity repository for to interact with the database, you need to actually register it inside the module itself. So what we need to do is inside the users module, inside imports, we're going to reference TypeORM module, and I do need to import that. So import TypeORM module from NestJS TypeORM, and then we're going to call the forFeature method, and then we're just going to simply pass in an array of all of the entities that we're working with. Since we're only working with user currently, we're just going to pass in the user entity. Okay, and that's it. And now you'll see that the error goes away because we actually added this entity in the scope of this whole module. TypeORM needs to know that. So that's why we needed this step. All right, so now we can actually interact with the database. We can reference this, user. Let me just show you real quick. We can reference this user repository property, and we can see that there are a bunch of different methods that we can use to retrieve data or create data. Okay, so what we'll do first is we'll create a method inside user service that will get us all of the users from the database. So that'll just simply look like this. I'll do get all users, or I'll just do get users, and I'll just simply do return this user repository. And to get all the users, you just simply use the find method. That's it. This will give you an array of users, and this method is asynchronous, so it'll return a promise. So we need to make sure when we call this method, get users, that we await it. Okay, because this will return a promise, and get users is now asynchronous, so we need to await that call. Okay, so let's go into user resolver. Let's go back into get users right over here. So instead of returning mock users now, first let's actually make this get users method async. And then we're going to do one more thing. We need to actually inject the user service instance into the user resolver, but that's very easy. So like I said, you should already know this if you use NestJS, so I'm not going to really explain too much about it. But all we need to do is just inject it by simply just creating a constructor. And there's two ways they can do this. You can either use inject like this, and then you can actually use the user service class as the token, and then private user service, and then type annotate with user service like this. Okay, then you can actually do, you can reference this style user service and then call get users like that. Okay, the other thing that you could do to keep things simple is you don't even need to use this inject decorator. You could just do private user service like that. Okay, I'll leave it like this for now just to save some space. But let's go ahead and call this dot user service and call it get users. And I actually don't even think we need the async keyword as well, because we're just returning this data, and NestJS will take care of resolving it for us asynchronously, because we're not using await as well, so we don't need that. So there are no errors in the console. That's good. Let's go into our GraphQL Playground, and if I click play, no errors, which is good, but it does return an empty array, and that's perfect because we don't have any data in the database at all. If I were to use the select asterisk from users query, we get an empty set because we don't have any data. Okay, well, let's change that. Let's go ahead and modify our mutation. Instead of actually adding the data to the mock array, let's actually add it to the database. Okay, so what we'll do is we need to first go back to the user service file. We need a method to actually create the data in the database. So I'll create a method called createUser. And what I need is I need the username as well as the display name. Display name is optional, of course, so we don't necessarily need it, but we will provide it if it is provided as an argument in the object. So let's do this. Let's see. I want to see if I can reuse create user input. Yes, I can reuse this class, so that's good. So what I'll do is I'll reuse this class. I do want to actually mark this display name as optional. So what I'll do is this, create user data, and then I'll reuse the create user input class. Okay, because we can, because it's the same thing. If you don't like to do that, you don't have to, but I'm just going to keep things simple, so I'm going to reuse that class for now, because it's the same exact thing anyways. Okay, and then to save the data to the database, what we need to do is we first need to create a variable called new user, and then we need to reference the user's repository, and then we need to call create. This is a synchronous method, so we don't need to await it. And then what we do is we just pass in the appropriate data. So we pass in username or display name. In my case, I'm just going to pass in the entire create user data object, because that will have username and display name. Once we create this object, we need to actually save it to the database. Okay, and we do that by simply calling this user repository.save. We pass in that partial, which is what this new user is. And that's it. And this will actually return a user, or a promise user. So let's actually just return this call. We don't even need the async keyword because we're just returning this. And then in the user resolver, all we need to do is we can delete all this stuff now and just return this user service and call that new method that we just created, create user. And then all we're just going to do is pass in create user data, just like that. Very simple. Okay, let's just double check our logs, make sure there's no errors. Okay, now let's go ahead and try to create a user. Let's see. Okay, yeah, username and display name. Let's click play, and there we go. We have no errors at all. We have an ID of 1, username and display name. If I go into the database, you can see that I have 1 record in the user database. That's perfect. Let's try to create a record without a display name. Let's make sure nothing errors out. So let's set the username to Anson. So now you see how there's a problem. And this is actually TypeORM failing because GraphQL knows that this is a nullable field, but TypeORM does not. So what we need to do is we need to go into the users module, and where display name is right over here, right? Inside this column decorator as an argument, we can actually pass in nullable set to true, and that should fix the issue for us. So let's go back here and let's click play and see how now I can actually omit the display name value and it just works fine. So let's create another record, set display name to Jack, and it works perfectly. Okay, and if I go back to my get users query, I can get all of the users. Okay, yeah, this is fine. It's working appropriately. The settings, the user settings is still being resolved with the mock data, which we will change. So don't worry. That's why you're seeing this settings part. Don't worry about that because it's still using the mock settings. But it's still working fine though because we actually have users now that are being returned from the database. And that's great. All right, so let's take a look at what we have so far. So let's see, we have create user and we have get users. Let's fix get user by ID. So now I'll show you how we can simply just query the database based on an ID for the user. And that's going to be very easy as well. We'll create a method inside the user service class called, not create, sorry. Let me go up here. Get user by ID. This will expect an ID, which is going to be a numeric value, a number. And all we need to do is just call user repository, find one. And then, actually, I think we can do find one by, and then set the ID like that. Yep. It's find one by, not find one. Sorry. So let's go back into the user resolver. And instead of referencing mock users, we now will do this user service get user by ID, and then pass in that ID. And let's check it out. So since our data is persisted, we should be able to get the user by ID. So I'll create a new tab for this query. Get user by ID. ID will be, let's do 2. Let's do ID, username, display name, and settings. For settings, we'll do user ID, receive emails. Okay, and there you go. We do get the actual data from the database. Okay, this is the actual user that we created earlier. Okay, and we got it by the ID. All right, very, very, very simple stuff. Hopefully that makes sense. So far we fixed get user by ID and get users, and also the create user. So now let's go ahead and migrate user settings from using the mock data to actually the real data. So first, what we need to do is we need to actually have a way to create user settings first. Okay, but we also need to work with the user settings repository, because remember, user settings is its own entity. It's not part of user at all. Okay, so in order to modify stuff with user setting, you need to work with the user setting repository. So just to keep things simple and avoid creating a bunch of different modules, I'll just keep the user setting service inside this users folder. So I'll create a new file and I'll call this user setting service.ts, like that. And it'll be the same thing. It'll be a class with the name user setting service. So export class user setting service, and we'll use the injectable decorator to tell TypeORM, or I'm sorry, tell NestJS that this is a provider. Of course, it doesn't want to auto import, so just copy and paste that right there. All right, so now we need to actually inject the repository, the same thing that we did with the user service. So again, this should be very straightforward if you've worked with NestJS already. So we'll just do inject repository. And I do need to import that as well. Okay, and then we're going to pass in the entity that we want to work with. So that's going to be user setting. And then we just need to give our constructor argument a name. So user settings repository. And then we just type annotate it with this repository generic type and set that generic type to be user setting, like that. I do need to import repository from TypeORM, so let me do that. Okay, so we're done with that. So now let's go ahead and create some methods inside user setting service, so that way we can actually create the user setting and also get the user settings. So first one that we'll do is get user settings by ID, or get user setting by ID. So this will take in the user ID itself, which will be a number, and then we'll just simply need to call the find. Whoops, sorry, this dot. Why is this? Oh, I'm sorry. I needed to add the private keyword in front of this, in front of user setting repository. So now I can reference this dot user settings repository find one by, and then user ID. So this will search for it based on the user ID. So this will be used when we actually take care of resolving the data, okay, or resolving the field for settings. Now let's go ahead and set up a method to create user settings. And we are going to reuse the create user settings input class. Okay. Right over here. Let me see. Let me just make sure I have this correct as well as set up properly for TypeORM. Okay, yes, we do. Okay, perfect. And I think this should be okay. Let me also see this class as well. Okay, I think this should be fine, but I think I do need to do one more thing though. In the column section, I do need to set the default values to false for both, because these could be nullable. Well, actually, they won't be nullable because we have a default value, but I'll set the default value to false. Okay, so what we'll do is we'll reuse this create user settings input class to type annotate the argument that we're going to pass into create user settings. So I'll call that argument create user settings data, and I'll type annotate with create user settings input class. And then all I need to do is the same thing that I did when I created the user. Okay, it's a two-step process. So first you create the actual partial of the user setting. So const new user setting equals this dot user settings repository dot create, and then we just pass in this object into that create method. Okay, and then we'll go ahead and return this dot user setting repository dot save new user setting. Okay, perfect. So now what we'll do is we need to also go into the users module. We need to add this user setting service as a provider. Same thing that we did for user service. Let's import that. And again, you should see the error that's complaining about the user settings repository. And again, that's the same reason, that's the same error that we had when we tried to add the user service provider, but we didn't have the user entity registered in the scope of our user module. So all we have to do is just go back up here where we have our for feature method being called. Inside this array, you just have to add the user setting entity. Okay, and that's the same class that we created, that we used for GraphQL. Okay, and now that error goes away. And there we go. So now we can actually go back into the user setting resolver. And well, yeah, let's do this. Let's first modify the user settings resolver first. So instead of adding it to the mock user settings array, we will go ahead and first, let me see. You know what? Let me actually do this as well, because I just realized something. Because since user settings resolver is a provider for the root app module, when we actually try to inject the repository, we need to redo the same thing. We need to add it inside the root app module. So to avoid doing this over and over again, what I'm going to do is I'm going to remove this user settings resolver as a provider from the app module. I'm going to I'll leave the file here for now, but inside users.module.ts, I'll just simply import the user settings resolver class as a provider in here, and it'll still work just fine. All right, so now inside our user settings resolver, let's go ahead and inject the user settings service that we just created. Private user settings service, user settings service. Okay, everything looks pretty good. Nothing wrong with this at all. Okay, perfect. All right, so let's go into this create user settings method, which is our mutation for GraphQL. And instead of just returning this plain object that we pass in, which is not correct, what we're going to do is we're first going to, let's delete that. Let's first create the user setting. So const user setting equals, and this time we actually need to use async await. So let me add the async keyword in front of this method, and I'll await this create user setting call. So this dot user setting service dot create user settings, and I'll just simply pass create user settings data, which is the object that has all of the fields that we're using to create the settings. Okay. All right, and now what we want to do is we already have the new user setting created, because remember this method itself created the partial and then it saved it to the database. So now when we await this method call, it resolves the actual user setting record from the database. So I can just simply return user setting just like that. So let's test this out. Let's make sure it works. Console has no errors. So let's go into create user. Oh, I'm sorry, create user settings. Okay, and before we do anything else, I will quickly go into my database and show you what it currently looks like. You can see that settings user ID is currently null. Okay, so what we can do is we can actually create the user record. But here's the other thing that we also need to do, though, is not only do we have to create the user settings, but we also, I forgot to mention this as well, we also need to make sure we're linking that user settings to the correct user. Okay, because it's one thing to create the new user setting, but we need to make sure that since we're using a relational database and we already have a one-to-one relationship between user and user settings, that we're linking it correctly. Because if we don't, these fields are going to be null, and that's not good. Okay, so to do that, we need to go right over, let's see. Okay, so right over here inside create user settings. Okay, so when we create the data, we're calling user settings service.create user settings. Okay, that's fine. Then we go into user settings service, and this is where we're working with the user setting repository. So we actually do need to inject the user setting or the user repository. So here's what I'll do. I'm going to go ahead and inject the user repository. Okay, and that got imported up over here. Let's make sure there's no errors. Okay, there shouldn't be, because we're in the same module and both of these entities have been provided already. So we don't have to worry about that. So we need this user repository because what we need to do is, one, we need to actually make sure that the user actually exists. So we actually do have to do a check in the database. So I'll do this very quick. So const find user equals, let's use async await. So async await this dot user repository dot find one by, and we're going to find by the ID, and we have the ID inside this create user settings data if we just reference the user ID property. So if find user does not exist, we'll throw an error. I think there should be a GraphQL exception class that you can throw. I'm not too sure, but I'll just throw an error. User not found. Okay. If the user is in the database, then what we'll do is we'll create the user. Okay, we'll create the user settings. We'll save it. And then what we will do is we need to go ahead and actually update the user itself. So I need to go ahead and do find user dot settings equals saved settings like this. And then I need to go ahead and call this user repository dot save find user. And then I can return saved settings like that. So it's a good thing I remembered that. All right, so let's go back into our code and let's go back to get users. Seems like, yeah, it's still resolving the mock data because we haven't changed that yet, but let's create a user settings right now. Okay, so pay attention to the table right now. I have 3 users. Okay, we're going to create user settings for user ID number 2. So let's do that. Okay, so it worked and there were no errors, it seemed like. Let's go into our database. Okay, perfect. Now you can see that right over here, settings user ID, which is going to be the ID of, I'll show you right now. So what setting user ID is, that's actually the reference key that allows us to know which record this references in the user settings table. So by us setting it to 2, that tells us that, hey, this record for Anson, in order to get the correct user setting, we have to reference this setting user's ID, which is 2, in the user settings table itself. So that's how we would get the appropriate user setting for the user. Okay, so we have it working just fine. So let's do the same thing for, well, let's actually try to do this. Let's try to create a user setting for a user that doesn't exist. So we know we don't have a user ID of 10. And you can see that we do get an error, so this is good. And of course, on the client side, you would have to handle it accordingly. Okay, but let's create a setting for user ID of 1. Okay, so that's good. So now we have user settings for user ID 1 and user ID 2. Let's create one for user ID 3. Perfect. So now let's go ahead and go back into our user resolver. So where we are resolving that settings field. Okay. And then what we will do is, instead of referencing the mock user settings, is we'll actually resolve the data by actually querying the database. Okay. So this is what we're going to do. We need to inject the user settings service into this user resolver class, because right now we're trying to query the user settings table. Okay, and we have all of those methods defined in that service class. So I'll add this in the constructor, private user service setting, user setting service, sorry. Let me actually change this real quick. User setting service. Okay, and then what I will do is simply go to get user settings. Let me just make sure there's no errors, of course. Okay, good. Right over here at get user settings, I'm going to go ahead and return this dot user setting service. And remember how I created this get user setting by ID? Well, this is where it's going to come to use. We want to get the user setting by ID, so we have access to the parent already. So I can reference user.id. Okay. So this is good because now we can get a list of users and it'll resolve all of the settings correctly based on the user's ID. Okay. So whatever the user ID is, we'll pass that as the argument to get user setting by ID. And of course, we're assuming that those IDs are going to be consistent across both of the tables, both of the records in the tables. It's up to you to make sure that you do that. So if I go back into my GraphQL Playground, and watch this, if I click play, Now, every single user has settings, and this is all data from the database. Okay, that's all it is. All right, we have get users, and then we have all of our users over here. If I try to do get user by ID, you can see that I have the user for ID number 2, and then its settings as well. Okay, so hopefully that makes sense. Now you all can see how powerful GraphQL with a database like SQL and an ORM like TypeORM is. Now this is the last thing that I'm going to show you all, because I did mention earlier about the problem with querying multiple databases, and I'll actually show you real quick. If I go into app and if I enable logging, this will actually show you the queries that are happening. Okay, you can see all these queries that are occurring right now. So what I'll do is I will call get user by ID, or I'll query get user by ID. And now watch this. We did one query for user, okay? And then we did one query for user setting. And you see how it says select user where user ID is equal to question mark, which is whatever the user ID that we passed in. And then we did the same thing right over here, select user setting where the user setting.id or .user ID is equal to whatever we passed in. Okay, so that's two queries right over there. Now let me show you real quick what happens is instead of having two queries occurring, let's say we want to get the user and all of its relations at the same time. So what I'll do is I'll go over to, well first, you know what, let me do this. Let me actually comment out this resolve field query. Okay, our stuff will still work fine, so don't worry about that. There's no error right over here. But what I'll do is I'll go to the user service. Okay, I'll go to where I am, where I have the get users method, and right over here inside this find method call as an argument, I can actually specify the relations that I want, and all I got to do is just provide the relation field name, which in our case it's settings. It's whatever this name is right over here. And now watch this. If I actually were to let's see, this should actually give us back, am I using the, yeah, I'm using the wrong query, apologies for that. If I go over here, okay, see how now when I query get users, it gives me all the users with its settings. Now let me actually go back here and remove this. Okay, notice how now it's null. Okay, so notice how when by default TypeORM won't give you those relations. You have to actually opt in it. You have to actually say, hey, I want these relations. Okay, before though, we were using GraphQL to make another query to get the user settings. But with TypeORM, when you're using a relational database, you see how what I'm saying is you can select whatever relations you want, and it does it in one single query. So let me actually add this right over here for find one by. So I can add relations. Let me see. I think I need to use a different method actually, because I don't think I can. Yeah, I need to use a different method for this. Let me try find one where ID is equal to ID, and then relations settings. Okay, so this is what the argument looks like. And now watch this. If I go back to get user by ID, notice how I can actually now get the user by its ID, and I can also get its relations. I can get the settings. And if you look at the logs over here, you know, let me actually reload everything. Okay, so if I run this query again, notice how now we only have one single query, this one single select query. Okay, that's going on. And you can see over here, I mean, up top over here, it says select distinct alias, user ID. Okay, and then over here we have select user. Let's see. Yeah, so we really only have one query to the user table, and then it's joining it with the user settings table, and it's going to give you the correct relation. Okay, you can see over here I have user settings, a user ID of 2, receive email is true, which it is, right? Receive emails is true. Let's do receive notifications. Well, the bottom line is yes, it is correct. So hopefully this helps you understand why I was mentioning earlier about using, something like SQL with GraphQL, and it's not like unproductive. It kind of just is a little bit contradicting to each other, because when you use GraphQL, you are primarily going to be resolving each field by calling either an API to get the data or a database or whatever external source to get the data. Okay, and that requires multiple calls. When you have a database that's relational, it can take care of getting all of the necessary data for you, because that's the whole purpose of a relational database. So you don't need to use GraphQL for that. So I bring this up because hopefully that will give you some context on when it's appropriate to use GraphQL with a certain database. In my opinion, I think GraphQL works best with a NoSQL database like MongoDB, but you can still use it just fine with a SQL database, because, for example, I can remove this settings field and I'll still get only what I want. However, the database still will do that join with the user and the user settings table to get that single record with all of the data. It's just that the GraphQL server will ensure that it doesn't give you back the settings. Okay, so really, again, you can't go wrong with going about it this way. But like I said, I wanted you all to see this for yourself so you can make an educated use case for your project. Well, that's going to be it for this video. I hope you all enjoyed it. If you did, please leave a like down below. It really helps out the channel a lot. If you have any questions regarding the tutorial, or if you have just questions in general, just leave a comment down below. I do my best to respond to all the comments whenever I can. And if you want to, subscribe to my channel. I try my best to upload as many informative videos as I can. And once again, check out the description, because there will be a link to the GitHub repository so you all can use it as a reference. So thank you for watching, and I'll see you all in my next episode. Peace out.